Have you ever gotten chills when listening to music? You know, that literal tingle that runs down your spine? Maybe you've had the same experience when listening to someone's awe-inspiring story. Well, some people actually search out this sensation with something called the autonomous sensory meridian response, or ASMR. Some people argue that everyone experiences ASMR. There's different triggers for this sensation. Some people have it when listening to whispering or soft speaking, or when close personal attention is put on them. Other people experience it with soft touch or delicate hand movements. Crisp sounds also tend to be a trigger. Nonetheless, this ASMR, or autonomous sensory meridian response, is something that has exploded in the media over the past decade. In fact, it's the third most searched term on YouTube. And the most popular ASMR channel has 860 million views across the channel, 2 million subscribers, and over 13 million videos are dedicated to ASMR on YouTube. Now, maybe you've heard of ASMR, maybe you haven't, but either way, today we're going to talk about what ASMR is, why it happens, and what's going on in our brain when this all happens. So once again, thanks for coming to Neuroscience, the best place on YouTube to increase your neuroscience IQ. Before we get started today, make sure you subscribe if you haven't done so already so that we can keep making neuroscience videos. Other than that, sit tight, stay tuned, let's roll the intro. So, first things first, what is ASMR? Well, like I said earlier, ASMR is the autonomous sensory meridian response, or a sensation of tingling that starts typically at your scalp and runs down your spine. Now, this experience of multisensory integration is something that's actually been studied in neuroscience before, and it has the term synesthesia. So synesthesia is this neurological phenomenon that occurs in only 4% of people, so it's very rare, and it's this union of sensation. For instance, some people, when they listen to music, they also sense colors. If you want some popular examples of synesthesists that have lived and are living in our world, Pharrell Williams, the guy that sings Happy, clap along if you feel like happiness is the truth, he hears music and experiences the sensation of color at the same time. Billy Joel claims that the same thing has happened to him. Vincent van Gogh was also a claimed synesthesist. Now, how is this happening? It seems that there's some sort of synaptic crossover between sensory systems. So the auditory system and the visual system are being activated at the same time when somebody is listening to music, if they see colors when they hear music. There's also connections in some people with literature and colors, where certain words lead to the experience of different colors. And so if we look at fMRI studies, we can see that visual areas are lighting up when people are exposed to sound, in the example of auditory synesthesists. So if we look at this example, the light purple is the visual area and the dark purple is the grapheme area, or the area for words and sounds. If we look at the synesthete, we see that they are activating both areas. So we look at activation with the red, and the red is activating both the grapheme area and the visual area. In the control, we only see activation of the grapheme area. So the dark purple is the only area being activated by sounds. Now back to ASMR. So ASMR is specific to visual and auditory stimuli activating the sensation of tingling, and then that leads to a feeling of relaxation. So apparently, auditory sensations, and for some people visual sensations, are activating this somatic sensation of tingling, but they're also promoting relaxation in the individuals. If you don't believe me, let's look at the science. In 2018, a paper called More Than a Feeling by Julia Poerio was published, and this showed that in people that experience ASMR, when they watch ASMR, they have a slowed heart rate and increased electrical conductance of the skin. Now, let's think about relaxation for a second. This might seem a little contradictory because when you relax, yeah, we understand that our heart rate would slow. So that response makes sense. But what about the skin conductance? What is that test? The skin conductance test looks at little minute changes in the amount of sweat. So if you've ever been stressed out, you might have sweaty palms or you might start sweating, and this causes the conductance on your skin to increase because in our sweat there's also salt, and that conducts electricity. So the more wet the surface of your skin is with sweat, the more conductance there is. So how come if ASMR is leading to relaxation, it is causing an increase in skin conductance? Well, we're going to get into that. Now first, let's prove that ASMR is something that's being experienced. So if we look at this table, we see a 2x3 study design. So there were two groups being compared, people that experience ASMR and people that don't experience ASMR, and then they went through 3 different treatments. So we have the control treatment, which is just to look at a baseline, then we have when they watch ASMR videos, and then we have when they watch ASMR spoken videos. So one was just sound and one was with speaking. Now, if we look at the 3 different groups across all treatments, the ASMR people report more sensation of tingles throughout. So there were significant differences between ASMR and non-ASMR people, no matter what treatment was delivered. If we look at the affect of this, we explored excitement, calmness, sadness, and stress. When we look at this, we see a significant difference between excitement, calmness, stress, and sadness, only when the individuals were watching ASMR. So, during conditions where ASMR was being watched, we saw more excitement in the ASMR viewers. We also saw more calmness. Now, this might seem a little contradictory, but the excitement could come from when they're actually experiencing the tingles, and then the calmness is the rest of the duration. What we saw less of was we saw less stress and less sadness in people who experienced ASMR. Now, when I say people that experienced ASMR and people who didn't experience ASMR, I don't mean they weren't watching ASMR videos, I mean they just don't get that sensation. Personally, when I watch ASMR, I feel a little cringy and uncomfortable, so I have never had that tingle sensation. I've had the tingling when I listen to music, but not watching these videos. Anyway, moving on to the second part of the study where they actually looked at the physiological response, we see the increase in skin conductance and the decrease in heart rate. But why is this happening? So we talked about the fact that decrease in heart rate is related to relaxation, and then we talked about the increase in skin conductance and how that result was a little bit strange. What the researchers suggested was that ASMR is actually evolutionary, and it's related to comfort and security and close pair bonds. So the reason why mouth sounds and close personal contact might be triggering ASMR is because it brings in a sense of closeness. It can trigger comfort from that idea of being close to someone. So why would we sweat more when there's a social interaction? Well, they suggest that perhaps we're sweating more because there is a release of endorphins, which is important to social bonding. So maybe the heart rate is being reduced because of relaxation, and then we're increasing our skin conductance as we release pheromones into the environment. So we have this idea of ASMR being important for social connections. Maybe it's some sort of reward for getting close to someone. So if we look at Maslow's hierarchy of needs, we actually have physiological needs on the bottom like food, water, etc. And then safety needs, so in modern society that would be like employment, security. And then if we move up one more notch, that's where we get into love and belonging. So social interactions are rather important, and if you think of it, social groups can also promote security and safety as well, which is even lower on the scale. And it can also help our physiological needs, which is on the bottom of the scale, by helping each other out with food, water, and those things. So could this tingling sensation and this feeling of relaxation be some sort of reward for a social interaction? Maybe. But let's look at what is going on in the brain. So it's hard to study this, it's hard to know what exactly is going on in the brain, because usually we turn to things like fMRI. And fMRI machines are very noisy. If you've ever been inside one, it's like this tube and you lie down inside, and then the magnets whirring around and stuff make a lot of noise. A lot of clanking, and so it's not a very natural environment, especially when you're doing something like watching a video that's supposed to make you relax. Nonetheless, there have been studies done, and in 2017 a study by Smith, Fredborg, and Cornelsen looked into the possibility that perhaps it's working the way synesthesia works. So perhaps we're activating multiple brain areas from one stimulus. So what they saw was that if we look at this image, the blue areas of the brain are areas that have less connectivity, and the orange areas are the areas that have more connectivity compared to a control subject. So we saw reduced connections between the frontal lobes and sensory regions in the precuneus and parietal cortex. So the parietal cortex, usually we associate that with somatosensation, and basically if we have reduced connections between these areas, it's said to be associated with reduced attentional control and inhibition in patient populations. Now, the frontal lobe is important for things like attention, thinking, and decision making. And when we think of it, it's like the control center. It's the part of the brain that allows things to happen and prevents other things from happening. So if we have reduced connection between the frontal lobe and other sensory areas, we're no longer able to inhibit those sensory areas, which might be why we're having this activity and this feeling, this somatosensory response to a video. So again, like I said, the parietal region of the brain is associated with somatosensation, and so if we have reduced connections between the frontal lobe and the parietal lobe, then we can't control the sensations that are being processed. They also saw reduced activity in the thalamus, and the thalamus is very important for sensation. Every stimulus in the environment, before it goes into upper regions of the brain, it goes through the thalamus, and the thalamus processes it and says, this is where this information is supposed to go, and sends it there. So the thalamus is like the organizational center. You can think of it like a post office. Letters come in, they're organized, and then the thalamus figures out where to send letters. So what's happening if we have less activity in the thalamus? Well, maybe things aren't getting sent to the right places. Maybe things aren't getting sorted as well. And maybe that's why we're having activation of somatosensation when maybe somebody else might only experience auditory sensations. Now, the place that they saw greater connectivity was the DMN, or the default mode network. And we've talked about the default mode network a little bit in our meditation videos. This is what is activated kind of when your mind starts to wander or when you're daydreaming. So if we have greater connectivity in this area known for daydreaming or our resting state network, well, we're probably less able to inhibit the outer world processing and inner world processing. So less connectivity between it, while you can inhibit the DMN and you can focus on what's outside without letting your daydreaming take over. But if we have increased connectivity within the DMN, well, maybe this is why sensations become so prominent, or the act of watching ASMR videos will produce this relaxation and this kind of meditative state for people that experience ASMR. Now, that was that study. Another study at Dartmouth in 2018 tackled the question of what brain regions are active when people experience the tingling sensation. And so they did the same thing. They put the patients in an fMRI machine. So what was done, these patients sat in the fMRI machine and they watched 5 7-minute ASMR videos. There was a button they would press to report if they were experiencing pleasant, trance-like, relaxed, or tingling sensations. That's what they did, and then they recorded when there was kind of a baseline mood, when there was a relaxed mood, and when there was a tingling sensation. And we see that for the most part during the videos, most of the time is spent feeling relaxed. There's a little small slice of time when you feel the tingling sensation, and then another good portion is devoted to baseline emotion. If we look at the areas that were activated, the medial prefrontal cortex has been related to relaxation. So oxytocin release in the MPFC has been shown to mediate relaxation, and so we saw activity in the MPFC during ASMR. Maybe this relates to relaxation. When people were feeling the tingling sensation, that's when we saw an increase in activity in more areas. So during tingling, there was an increase in activity in the nucleus accumbens, the medial prefrontal cortex, the insula, and secondary somatosensory cortex. So if we look at the nucleus accumbens and the insula, well, these are reward areas, and these areas became regions of interest. So we've talked about the nucleus accumbens in other videos, and if we're looking into the fact that ASMR might be an evolutionary experience, and that's why we feel reward to promote social connectivity, well, the nucleus accumbens lighting up supports this idea. The insula is an important region for homeostasis. And so when we think of this region lighting up, I just think maybe it has something to do with the fact that we're activating the parasympathetic nervous system and everything's relaxing and kind of shutting down. These are just speculations, but the take home from this part of the video is what regions are active. We're not necessarily sure why, but we can speculate why. And then we get into the supplementary motor area being activated. And so this probably has to do with the tingle, the actual tingle sensation. If we're feeling tingling, there has to be neurons active in the somatosensory cortex. So the somatosensory cortex of the brain is the region in the brain where we experience feeling, or somatosensation is just touch. So if I touch on the hand, there's a region in my brain in the somatosensory cortex related to that. So they went in and looked even more specifically at which regions of the somatosensory cortex were being activated. They looked at the cheek, the lip, the forehead, and the foot area, and they saw higher activation in these regions. And they saw these regions were even more activated than when you actually touch the region. So the cheek area, if you touch it, it would light up on the fMRI, but also it lit up even more when they were experiencing the tingles. So that is what's going on in our brain. We have somatosensory regions lighting up, we have reward areas lighting up, a little bit of the medial prefrontal cortex, and the insula as well. We also have changes in connectivity with less connections between the frontal cortex and different sensory areas of the brain, and more connections in the default mode network, so the daydreaming network. We also said this experience of ASMR might be important for affiliative behaviors, so between parents and children, or romantic partners, or friends even. And we look into the possibility of oxytocin and endorphins in different regions of the brain relating to this, and also endorphins through our skin conductance. Now I want to extend this all to the fact that we're living in a world where loneliness is increasing. And a lot of the papers that I read about ASMR were suggesting using it to treat loneliness. So I want to ask you guys, what do you think? Could ASMR be used as a therapeutic tool in the future? I also want to know, have you ever experienced ASMR? Leave me your comments down below and your thoughts. Make sure you like and subscribe so we can keep making future videos. I'll see you next week right here on Neuroscience.